All right, AP Stats. Um, Welcome to this video. Uh, uh Sorry, I almost died. But another video. Just to progress our understanding of statistics. Just because I'm sick doesn't mean the learning is gonna stop. So, what I would like for us to do today is for us to finish at least one section since I'm gone. Not gonna give you too much, but we're gonna go through this together. So the activity or the notes for today is gonna be called "How much do you get paid?" So suppose that you get a job and you pick up a piece of paper every day, pretty much saying how much money you're gonna make per hour. So there's a chance for you to get $1 per hour, $5, $7 an hour, etc., etc. So I have this table which pretty much just shows, the probability of you drawing these. So if I had 30 people in my experiment, 3 people got $1, 5 people got $6, and so on and so on. So we have to interpret and calculate the expected value, which was the equation that we learned last class, which is mu is equal to the summation of the possible x values multiplied by their probability. So, like for example, 1 times 3 over 30 plus 5 times 6 over 30, so on and so on and so on. So let me give you some time to try that and try to find your own answer. You can pause the video at this time. I'm going to show you the answer in 5, 4, 3, 2, 1. You get $8.40. And in this, we want to interpret it, so we're gonna actually write in English what this $8.40 means. So $8.40 is our expected value. If we draw, you should write smaller. I can't. Many wages. The average average is about 840. My handwriting is really bad right now because I'm not healthy. Perfect. All right. So number 3 says to recall chapter 1 standard deviation equation. We're gonna just meh. I'll give you the equation later, but what I would like for us to do is actually come to this table and try to fill it out as much as possible. So if I draw a 1 and I use this $8.40, how far is a dollar versus the 840? And that distance, well, I can do 1 minus 840 is negative $7.40. So you should do these for all of these values, but I'm going to show you this row. Okay, so I have this negative 740, and now they're trying us to asking us to find the distance of the mean squared. So what is negative 7.4 squared? Well, that's $54.67. 76. Oh my gosh, I'm not okay. All right, and the last thing is that I need to find the weighted distance. So I'm gonna take this $54.76 and I'm gonna take the weight which I found for number 1 based off my table. So this is 3 out of 30. So that becomes 5.476. So this activity might look very familiar from our previous notes. So what I would like for you to do is try to do all of these and find the total when you add up all of these slots right here. And you're going to find the total. And this total is going to be representing our our variance. And we know that the relationship between variance and standard deviation is that standard deviation squared is variance. Or the square root of variance is equal to the standard deviation. So I would like for you to try to fill out this table yourself. I'll pause it, and then we're going to interpret the standard deviation, or we're going to write in English. So remember this, interpret means in English, what is the probability? Or like, oh, sorry, what is the standard deviation? So try this out yourself in 5, 4, 3, 2, 1. Okay, so table filled out, boom. And we're going to interpret the standard deviation right now. So remember that the standard deviation, like the official title or the official definition I gave it, is the average distance from the mean. So in this context, it's the wages typically vary by $4.76, which I found on my table, from the mean of $8.40. And I got this 840 from here and here. So if this person decided she would rather assign wages so that employees get, between 10 to 20 and are likely to be chosen equally, draw a graph that represents this probability. So equally likely, that means that like everyone has equal amount of chance of you getting like $10, $20, $15, $11, like even like 11.45, blah 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 blah. So we're gonna draw a picture. I'm gonna try to zoom in here. Ah, here we go. I'm gonna draw a picture, and if I start at 10 and I go to 20, this this width right here is going to be 10 units, right? Because, I mean, on a number line, 10 to 20, this is 10 units away. So that's 10. And we learned this from like a early unit, but if it's equally likely, that means the area of this box right here has to has to be the area has to equal 1. So if that's 10 units, this right here has to be 1 over 10. So this is going to be 1 over 10. So if I draw this, I'm going to draw this box a different color than black. So if I have a if I have a box right here like this area is going to equal 1. And just for a reminder, this is called uniform distribution. And it's called uniform distribution because uniform pretty much means like equal. So there's an equal chance of you getting whatever value from like, 10 to 20. Between $10 an hour to $20 an hour. And of course you would label this. So this would be like your wages per hour. And this would be like your probability. So number 6. You don't need this. Number 6. What is the probability that you would make, $12 or between $12 or $12.50? So if I use the same picture, which I'm going to, I'm going to label this $12. I'm going to label this 12.5. Yes, it's not in scale, but meh. this area right here, I can find it using our core geometry equations. So remember, area is length times width. So if my length, whichever one, is, well, the distance between these two things right here, that's 0.5 units. So this is 0.5. And, well, if I have this part of the box as 0.5, then this of the part of the box has to be 1 over 10. So in the end, 0.5 times 0.1, or I'll write it as 1 over 10, is equal to the area, which is equal to 0.05. So they're saying that you have a 0.05 probability of you getting $12 or between $12 and $12.50. So a 5% chance of that happening to you if this is true. So in the end, go to our learning targets. There's a couple things that we talked about, just two. Learning target number 1, we talked about the standard deviation. So just this is the equation that we did in total, but it's not really that important. But conceptually, we just do it once so that we can never do it again. So the summation, or the square root of the summation of the x value minus the mean squared times the probability of the value. So this equation is from like that table that we just did. Oh, I need one more line. Where it was like 1, negative 7.4, 54.76, and 5.476, and that added all the way down to this right number being 22.64. And remember, this is the variance, and so this became the standard deviation, which was 4.76. So I just drew this picture just for reference, and I know that you have a lot of space, so why not? A good concept to also understand is that, so this is the standard deviation squared is equal to variance, which is pretty much the square root of variance is equal to the standard deviation. So that's learning target number 1. Learning target number 2, I'm just going to write it beside it because hopefully you have enough space. This is called, what I would like to call probability for continuous random variables with a heart, ugly heart. And really, what this is really talking about is like number 5, where we have this picture, we have, you know, this gap. Let's say, for example, this is 5 units away. So let's say this is 1 to 5. So this is 5 units. So that means that this right here has to be 1 over 5 units away. So this is going to be 1 over 5. And just know that this area of this box, let's start from here. The area does have to equal 1 because, well, area has to equal 1 because 1 equals to 100% of the possibilities. So just like the game that we did during our final exam project, you had to make a probability model that showed every single possibility. So this 100% is representing every single possibility. I'm going to also say that, you know, eventually we're going to have to learn this, so I'll just show you that now. That this is called uniform But there's another curve that we learned about, which has an area of 1. And it's called the normal curve, which looks like this, the bell curve. Where, we learned about this in Unit 1. This is called normal distribution. And we're going to start using this next lesson, or soon. I don't know when that's going to be. But just know that there's a lot of things that we have to label. So, of course, it's labeled by a big N with the mean and the standard deviation. The z-score, which is value minus mu, is divided by standard deviation. And we used table A. So, just a nice little reminder, we're going to be using this eventually, in my class. So, learning target completed. Let's talk about this check your understanding. I would like for you to try this yourself. When I come back to class physically, either it'll be due. I'll give you guys some time to ask me some questions based off of the check your understandings. I just pray that you would try this to the best of your ability. One question I thought that was hard was part C. So let's talk about part C. So if they're asking us what the probability of if y is less than or equal to 90, so if I draw this normal distribution very badly, and well, I'm going to label these accordingly to the story. So they told me in the story that the mu is 150 and that the standard deviation is 42.7. So I'm going to label this like so. 150, 42.7. And they're asking me if y is less than or equal to 90. So if this right here is 150, then like 90 is going to be like around here somewhere. And I'm going to draw this line like so. And I'm going to shade this in. And that's what I'm trying to look for right here. So, well, I'm going to use this formula. Z is equal to x minus mu divided by standard deviation. So if they said 90, so I'm going to put 90 here. 90 minus 150 divided by standard deviation. I got this 150 from here. I got this 42.7, which is our standard deviation. Oops. This should be 42.7. And I got this 90 from the question. Blah, blah, blah. I used the calculator. Z is equal to negative 1.41. I use table A, which you can find a link. Let's see. I logged in. Whoops. Come on. Come on. Come on. And important links. I don't have it. Table A. I have it here somewhere. Ah, here it is. I'll put it under important links. So you can find table A here. So table A, if I use table A, I have negative 1.41 is my z-score, so negative 1.41, which is right here. This is table A, which ends up being 0.0793. And in conclusion, you need to write in English, there is a 0.0793 probability of choosing a player who plays less than or equal to 90 minutes per day. So not too bad. So I would like for you to try number or part D by yourself where you draw the distribution, right? And then it's going to be between 45 and 90. So it's like here. It's going to be different than part Charlie. And hope to see you guys soon. Thank you guys. Bye-bye.